Starting with the three buttons, we have clear, generate, and remove occluded meshes. Clear and generate are pretty self-explanatory, but the remove occluded meshes, what that does is that if a mesh is underneath or very much buried under other meshes, it will attempt to remove that mesh. It is pretty crude, but it does help in reducing the number of instances. We have 4 different spawn types, starting with the persistent instanced static mesh. This is a HISM, so we do have LODs for these instance static meshes, and they are persistent, meaning that if you change level or exit the editor, they will still be there when you start it up. They are invisible in the outliner, so they will not be cluttering up with your other objects. We have static mesh actor, and what this will do is it will spawn a single static mesh actor per instance spawn. So if we hit generate here, we can see that it now spawned about 100 actors, and we can click on these actors and scale them, rotate them, or move them around, or even delete them. This is useful if you plan on batching or baking your static meshes. And then we have actor, and that will spawn custom actors. So let's say you have a vine generator and you want that vine generator to originate in an occluded area. You can pop it into the actor array and it will spawn those. And then we have the Niagara system, and this is basically self-explanatory, but it spawns a Niagara system. We have generate on construction, and what this will do is that it will spawn meshes when you move the volume around. So something to keep in mind when you have the generate on construction on is to keep the number of iterations quite low, otherwise it can get pretty laggy. But if you keep it low, it's pretty smooth. We have self-collision and trace complex collision. Self-collision is basically so that the meshes will not ignore each other when they're being placed, so they can stack on top of each other. And trace complex collision means that the trace will trace complex collision rather than simple collision. Oftentimes it's better to keep the trace complex collision off if you have simple collision for everything. If you have very complex geometry, such as a very rocky road or very many sticks in the forest, and you want to spawn stuff there, it will return a lot of false positives because the terrain is very uneven. So try to keep that off. And then we have auto clear, and what this will do is that it will clear the previously spawned instances every time we click the generate button. We have volume size, and this basically dictates how big the volume is. Keep in mind that the larger the volume, the more inaccurate the placement is. We have number of iterations, and this is how many times the generation script is run each time you press the generate button. So now we have it at 1, which means that it will only run once. But if we put it at something like 10, it will run 10 times every time I press the generate button. So it's good if you want to quickly get out a lot of meshes. Spawn tolerance is how occluded an area must be in order for it to return a positive hit. So leaving it at 1 will often be good enough, but if you have a situation where maybe you have a roof here, and let's say you only want these balls to spawn underneath here, because this is obviously more occluded than this area, we can turn that down to something like 0.5 perhaps, and now they only spawn underneath the roof. We then have the fine-tune tolerance, and this is for when meshes are spawning on edges, you can try adjusting this value, and that should fix the problem. We have the probe random offset, and what this will do is that it will randomly offset a probe in a random direction, giving the generator a more natural generation. So if we set this to 0, we can see that they're always kind of spawning in the same area. But if we put this to something like 1, which is the max, you can see that it's more random. Probe density is basically the resolution or accuracy of the volume. A value of 10 is usually pretty good. You can go lower or higher, but try to stick to around 10. Spawn quantity is how many potential meshes can spawn per probe. So if we have a probe density of 10, that means 1,000 probes, which means that a potential 5,000 meshes can spawn. Keeping this spawn quantity at around 5 is pretty good. You don't really want to go lower than 3, I'd say. And instead, if you want to lower the amount of meshes being spawned, you can lower the number of iterations instead. Collision profile. This is which collision profile is used for the spawned meshes. And if you go into the project settings under collision, you can see all the profiles there, or even make your own. And then you just type in the name and you should be good to go. Random seed and seed. This is basically the seed of the generation. This is a deterministic generation, so given the correct parameters and the same seed, you can recreate a specific generation if you want. Moving on to the placement, we have spread, and that is how far the mesh can spawn from its probe. And if we keep that at 1, it's pretty tightly constricted. But if we put it up to something like 3, we can get a more natural spread. We then have ground slope align, and this is at what angle the terrain can be for it to spawn. So 0.5 is pretty flat, and 0.25 is pretty steep. I think it's about 45 degrees. So let's see if we can demonstrate that. If we put it to 0.8, it will only spawn on almost flat surfaces, but if we put it to something like 0.2, it should spawn on this ramp right here. Yeah. And then we have align mesh to normal, and this will align the mesh to the normal where it is trying to be placed. So if we take the ramp again and align the mesh to the normal, we can see, actually let's spawn in a static mesh actor, and we can check out this one, for example, and we'll check the local z-axis. You can see that this one is aligned to the normal of the ramp. And then we have random yaw, and this is basically a rotation on the local z-axis. So if we take the ramp again, let's see if we can get there, and then we'll spawn in a static mesh actor, and the random yaw would be a rotation like this. It's hard to see because this mesh is, maybe if we scale it like that, but it would be a random rotation like this. And then we have tilt, and this is how much the mesh tilts from its pivot point. So if we bump that up to something really high, 20 to 40, we can see that these are, in fact, well, not that one, but this one is. It's pretty hard to see, but if we scale it up, we can see that it's tilted about 10 degrees. No, it can't be tilted 10 degrees. It must be 20. And then we have the Z offset, and this is offsetting the mesh on its local Z axis up and down. So if we put this to 20 and 20, we can see that they are floating in the air. This is useful if you need to put a mesh further down into the ground, like a tree that isn't quite pivoted correctly, so the pivot point might be a bit too far down or something. Or maybe the terrain is very uneven, so you need to place it down in the ground. Then you can do that here. So maybe -5 to -10, and it should pretty much bury these spheres. And then last but not least, we have scale, which is the most self-explanatory one of them all. It's just a random scale between this value and this value. So now this should be pretty varied in terms of scale. And yeah, that wraps it up. If you have any questions, join the Discord or send me an email. And thanks for watching the whole video.